Hi and welcome. This fog computing tutorial has been created as part of MIS coursework for the Department of Computer Science, University of Karachi. My name is Afnan Rehan and today I'm going to be walking you through fog computing. Now, what exactly is fog computing? Fog computing, also known as fogging or edge computing, is a model in which data processing and applications are concentrated in devices at the network edge, rather than existing almost entirely in the cloud. Cisco recently delivered the vision of fog computing to enable applications on billions of connected devices directly at the network edge. Customers can run, develop, and manage software applications on the Cisco framework of network devices, including hardened routers and switches. Cisco brings the open source Linux and network operating system together in a single network device. Fog computing reduces the need for bandwidth by not sending every bit of information over cloud channels and instead aggregating it at certain points. By this distributed strategy, we can lower costs and improve efficiencies. Now, what is the need for fog computing? As you can see in the diagram over here, we have a cloud and the fog is in the middle of the cloud and the user, which is shown in this diagram through tablets and other devices. Now, fog computing, what it basically essentially does is that it keeps the data right where the Internet of Things needs it. Fog computing extends the cloud computing paradigm to the edge of the network, while cloud and fog could use the same resources, that is to say, networking, compute, and storage, and share many of the same mechanisms and attributes. The extension is a non-trivial one, that is, there exist some fundamental differences stemming from the reason fog computing was developed to address applications and services that do not fit the cloud paradigm. That was the reason fog was so essential. Now, speaking of the current system, we have a number of websites and a number of applications basically that use the current system, which is cloud computing. Now, it is, I believe, essential over here to mention the example of Zynga, which is a gaming website which has billions of users throughout the day. But what they do is they use data centers and they use cloud computing at the same time. And by that, what they do is they reduce the amount of storage that they require at their own end, and they can instead just use pay-on-the-go services. As explained over here, cloud computing has many opportunities for enterprises by offering their customers a range of computing services. Now, Zynga is important here to mention again because they don't require as much storage facility as other companies generally would due to the introduction of cloud computing. The current pay-as-you-go cloud computing model becomes an efficient alternative to owning and managing private data centers for customers facing web applications. Now, of course, there are some limitations of the current system which kind of developed the need for fog computing in the first place. Let's take a look at some of those. Cloud computing has disadvantages at the same time when it also has a number of advantages. Now, the disadvantages of cloud computing basically revolve around security. That is to say that existing data protection mechanisms such as encryption fail in securing the data from attackers. Users found that their data was not as secure as they believed that it would have been, and that's why they had some issues about data integrity and data security. Now that the fog has arrived, making data more closer in terms of, in fact, as compared to the cloud, I believe users are more trustworthy with regards to the fog now that they have proof that their data is more closer to them. The current system does not verify whether the user was authorized or not. Cloud computing security does not focus on ways of securing the data from unauthorized access. Now, that kind of found the need for forming fog computing in the first place. And as you can see over here, we have a number of devices which have the fog in the middle instead of being directly connected to the cloud. Fog sites allow real-time data processing, data caching, and computation offloading. And cloud data centers are basically used for big data management and mining and machine learning. So now we're going to be talking about some of the limitations that fog computing has overcome. Reduction in data movement across networking resulting in reduced congestion. That means to say that since certain access points are places where bandwidth is aggregated in fog computing, instead of every single bit of small or big information being transferred directly from end devices to the cloud, we have a sort of a barrier now which acts in the form of fog computing in the fog. So that is how we can reduce congestion and increase security due to encryption of data, because obviously it stays closer to the end user as compared to cloud computing. Thank you for watching the tutorial. I hope it helped, and if you have any questions, leave them in the comments below. Thank you.